Hey, folks, we're going to be getting started right now. So, hey, my name is Phil Zito, and I am excited to welcome you to the Troubleshooting for Building Automation webinar. So, in this webinar, you are going to get some instruction on the troubleshooting process, and then we're going to go over to the whiteboard and we're going to talk through how to actually troubleshoot things. So, we're going to dive into that and we're going to have a lot of fun. If at any time you have any questions, then by all means, please ask your questions so that way we can answer them. The more questions you ask, the more interactive this will be, and the more entertaining and fun and just enjoyable it'll be all around for both of us. All right, so my name is Phil Zito. I'm the founder and CEO of Smart Buildings Academy. We are a provider of online skill assessments and training for building automation contractors, owner-operators, engineers, and individuals. I got my start as a technician, then worked through service, operations, sales, and prior to starting Smart Buildings Academy, I was running the technical integration program at Johnson Controls. I've created a lot of courses, done podcasts, done a lot of articles. I do live videos, so you've probably seen me around. Now let's talk about what we're going to cover here. All right, so our agenda is the 4-step troubleshooting process. We're going to talk through that. We're probably going to spend about 10, 15 minutes on that. Then we're going to go through a VAV troubleshooting example over on the whiteboard, and then we are going to go through the network troubleshooting example, and then we're going to go through a protocol troubleshooting example, and then we're going to have some live Q&A. Now, you should be getting a link sent over to you in chat to download a PDF, and that PDF is going to be a workbook that you can follow along as we present. Basically, it's going to have a lot of blanks in it, and as you go through the webinar with me, you're going to see things that are going to be in bold. And those things in bold are going to basically be what you fill out in the webinar. So that's what we're going to do. And eventually we'll get to the whiteboard and we'll have a lot of fun. All right. So let's dive in. So why do you have a process? What is the whole purpose of a troubleshooting process? That is to enable us to be able to go, yeah, I know there's no link. Nicole's going to get on that. So it enables us to identify the root cause of issues, right? It's going to make us able to identify the root cause, which is the biggest troubleshooting problem that you're going to run into. And then it is going to track actions taken towards resolution. So as you resolve issues, you will be able to go and remember kind of what you did. Because one of the problems I would have, especially with protocols, is I would start troubleshooting BACnet protocols, and especially before I didn't really understand how BACnet worked, I would go and I would be like, man, how do I go about figuring this out? And I would make all these changes, and then at the end of it, I would have no clue how to reverse what I did, and I was in a worse situation than I was when I began. Also, having a process helps us avoid excess effort. So hopefully by the end of the slide, you're sold that a process would probably be a good thing for you to have. One of the most important elements when you're troubleshooting is to eliminate all of this noise so that you can pinpoint the root cause. Because you're going to go to a job site and the customer is going to be, well, it never worked. It doesn't work. It's cold. It's hot. It's this. It's that. They're not going to tell you that they've been manually operating the valves in hand because that's just what they feel most comfortable with, and they don't trust the BAS system. They're not going to tell you that they didn't want to pay for that retrofit from their contractor, so they went and tried to do a retrofit on their own. You don't get a lot of the input, and that's not really a dig on owner and operators. They don't know necessarily sometimes that that's really important information for us, the troubleshooters, to understand. So oftentimes you will get a lot of noise, and you've got to flush through that noise in order to be able to pinpoint what exactly is causing the issue. So the troubleshooting process in a nutshell is 4 steps. We're going to determine the desired outcome. We're going to define the actual outcome. We're going to perform a root cause analysis, and then we're going to go through resolving the issue. All right, how do we determine the desired outcome? Well, the desired outcome, quite simply, is the state in which the object, so we're talking both physical objects as well as logical objects, device, or system should be in when operating normal. So, examples of this would be like your air handler. It should be providing maybe 55-degree air and a certain amount of CFM and maybe a certain DP, right? So, you want to go through that. The next thing is when you are looking at a desired outcome, it's usually linked to, but it's not always linked to the object, device, or the system that is in a non normal state. So, what I mean by that is the desired outcome, maybe a space being 72 degrees, that may be the actual issue, right? It may be linked to the issue, but it may not be the issue. And we'll understand that more as we start to get into the interrelationship concept, the multi-layer concept, things like that. All right, key point, identifying the desired outcome is the key objective to any troubleshooting scenario. If you figure out the desired outcome, what you're actually trying to solve for, it's going to make things a lot easier. All right, so how do we determine it? Oftentimes you can look at the opposite of whatever is not working, right? So you could say the desired outcome of a space that's hot is the space being at set point. The desired outcome of a unit that's not supplying enough air is the unit supplying enough air. However, not all customers are going to be capable of communicating what is wrong. And so there's kind of 5 questions I like to dig into that help me determine when I show up on a job site what my desired income is, or outcome, not desired income. That's a whole nother topic. Desired outcome and the actual state. All right, so the 5 questions are going to be focused on frequency and timing. What has been done to fix the issue, the current conditions, the current outcome, and the root cause. So frequency and timing, you're going to be like, hey, when does this occur? How often does it occur? You're looking for patterns that may indicate some other cause of the issue. What's been done to fix it? If you're going to go and try to troubleshoot things, then what's going to happen is you're going to go and have to figure out what has already been done to troubleshoot things. So you got to kind of reverse engineer it. The current conditions, we want to figure out kind of what the current conditions are, what is actually happening. And then we want to know the current outcome, what is actually the outcome of whatever changes have been made. And then we want to figure out questions related to the root cause. What have they done? What have they seen happen that could cause these issues? Defining the actual outcome. So, and folks, I know we're having some issues with the workbook. Don't worry about it. We will get that to you after the fact. There will be a recording. You can go through it and fill out the workbook. Zoom, this is the first time we've used Zoom for a webinar. So even though we've done a dry run, there's a few little kinks in here that we'll work out by next webinar. So step 2, define the actual outcome. Now that we have identified this desired outcome, maybe it's 72 degrees, maybe it's 1.5 inches of static, maybe it's a certain CFM. Now, the actual outcome is going to be the current state of the object, device, or system that is acting abnormally. So we're going to say if we have a zone temp of 72, or that's our desired outcome, and our zone temp is 64, then 64 degrees is our actual outcome. We want to know this because the actual outcome is almost always the fault, failure, or deviated state of our desired outcome, and it will tell us where to begin troubleshooting for our root cause. So where can we find it? We can look in multiple different spots, right? We can check our building automation systems graphics, alarm reports. We can do physical observations, which I highly recommend. We can go and have discussions with our customers, and we can look at external systems for like third-party integrations, things like that. All right, performing root cause analysis. So this is where you can spend most of your time besides for troubleshooting. If you get the root cause analysis right, then fixing the issue is often pretty easy. So performing a root cause analysis, it's the part of the troubleshooting process that often freezes folks up. They really struggle to do it because after all, going and figuring out the desired and actual outcomes are usually fairly easy. It's identifying the core cause of a system issue that is difficult. So for example, you got a data center, the BAS server should be up, but the BAS server is intermittently down. We asked one of our 5 questions around frequency. We determined that the server goes down at the same time. We went and checked the trunk link. We realized that there's a massive database upload going on in the data center at that time on the same trunk link as the BAS traffic. And the quality of service is taking down the BAS server, so the server's going down, and we've identified the root cause. That's kind of the thought process you have when you're identifying. I mean, that's very much simplified, but that's the approach you take. Now, root cause analysis, like I said, it's where you're going to spend most of your time during the troubleshoot process. You have to be careful to identify the correct root cause, or you're going to really mess up troubleshooting. That's where these interrelationship and multi-layer concepts come into play. So as professionals, we often get called to do things like hot and cold calls. Everyone's done a hot and cold call. Well, almost everyone, right? So you run into a hot and cold call, and it's almost, I don't want to say almost never, a good portion of the time, it's got nothing to do with the terminal unit. It actually has something to do with something upstream from the terminal unit. Maybe a smoke fire damper is closed. Maybe the air handler had its settings changed. Maybe it's tripped on freeze stat, whatever. Well, what happens is that while something may seem to be an easy to identify root cause, we can actually have interrelationships and multi-layer aspects of troubleshooting that causes us to not be able to identify the root cause. Let's talk through that. Multi-layer concept is going to be something that describes how issues they flux across multiple layers. So if we think back to a zone temp, which we're going to look at on the whiteboard in just a second. Now we think about it and we're like, okay, it's in the space layer, right? It's got something to do with the space. And then we start to think, how is zone temp controlled? Let's say we have a hot space. How is zone temp controlled when it's hot? Well, we increase to max CFM, max cooling CFM. And then if the DAT is right, if the SAT, the supply air temp coming into the terminal unit is right, and we are truly hitting max CFM, then the air changes should take over. And as long as there's no external sources of heat, we should, in theory, cool the space back down, as long as we're not out of design conditions, right? So the problem begins when, okay, we're driving to our CFM, but we're not maybe at the DAT we need. So our DAT from our air handler is maybe 62 degrees instead of 55. Maybe we've got a delta T issue at the coil. Maybe we've got a fouled coil. Or maybe we're an even higher layer up, which is the chiller. So oftentimes I say to folks, if you go to troubleshoot a terminal unit and all of the terminal units are not meeting set point, then that points to an air handler issue. And if you go to the air handler and all of the air handlers are not able to meet DAT, then that points to a hydronic plant issue. And that's kind of one of the things I see in newer folks troubleshooting. And this is true about networks, protocols, HVAC systems. When you focus in, and this is so easy to do when you got a customer screaming at you, or you're like going from service call to service call, or maybe you're on a warranty call and you need to get back to a project. It's so easy to focus in right on the zone temp, because us being in a calm situation right now, we're like, okay, yeah, we would logically just say, oh, well, what else could be going on? But when you're like trying to get something solved really quickly, you can have tunnel vision. And you've got to fight that temptation to tunnel in and step out and be like, okay, what is the space conditions? What is the air handler conditions? What is the hydronic? And always be asking yourself, what could cause this, and work your way up. That is the multi-layer concept. Now, the interrelationship concept is very similar, and it describes how issues across multiple layers are interrelated. So, for example, you can resolve a temperature by affecting a change on a new non-root cause issue. What would this look like, right? If we go back to our zone temp scenario and we raise the supply air pressure at the air handler to deliver more air, while not addressing a delta T issue or not addressing a hydronic issue, then sure, we're going to provide more air that has greater capability of absorbing BTUs and taking those BTUs out of the space by increasing air changes, right? So with that increased velocity, people are going to feel cooler just due to the evaporative effect, and we may actually remove some more BTUs. But now we're starting to starve other boxes. And so by not addressing the root cause, we're actually starving other boxes and we're going to create issues in other terminal units. I really hope you all heard that and it made sense, because this is one of the biggest issues I see when people troubleshoot is this interrelationship concept. They don't deal with the root cause, and then they make changes to kind of band-aid the situation. And they may not be intentionally doing that, but by doing that, they actually cause other issues. And then it starts to spiral out of control because now you have a bunch of interrelated issues and it becomes very difficult to troubleshoot. That's also why, if you recall very early on, I said we really want to have a troubleshooting process and we want to be documenting as we go so we're aware of what changes we make. All right, let me get back to that. So now we're going to go to resolve the issue. I mean, really, this is just going and resolving the issue. If you know what the issue is and you've really truly determined it, it's just fixing that issue. And this should be relatively simple. Yes, granted, if it's like programmatic in nature, it may require some reprogramming. If the system was poorly designed or undersized in the beginning, there's only so much you can do. I recall a music studio that was all wood, that was designed with a fan coil unit that was cooling only and had no form of reheat. And the idea was to take, and this was in the South, to take outside air in the middle of summer and mix it with the cool air, and somehow that would lower the humidity level, not paying attention to the fact that southern air is, 70% relative humidity at 90 degrees. There's no way, if you follow a psychrometric chart, that could fix the issue, right? That's a complete re-engineer solution. So it usually is relatively simple. It's not always easy. All right, let's continue. So the issue resolution process, first thing we're going to do, we're going to release any overrides that we've made. We're going to restore any set points. We're going to update documentation, especially if we make changes. We're going to redline things and update it. And then we're going to train the customer where possible on how to avoid this issue in the future. If the issue was caused by overrides or improper operation of the system, then we are going to go and train them on how do we avoid that moving forward. All right, so let's switch over real quickly, excuse me there, to the whiteboard. Okay, so actually let me turn off presentation mode real quick, and then we'll switch over to the whiteboard so you get full screen. There we go. All right, so let's talk through terminal units, right? So with terminal units, let's look at kind of that example that I made so that we're clear on what does this all look like, okay? So let's dive in here. All right, so we've got a terminal unit, right? VAV box, got a damper, got your typical cross airflow coming in to a VMA, right, with a T-stat. Our standard VAV cooling only box. We go into a troubleshoot, and we're going to look at a VAV cooling only box, and then we are going to look at a VAV with reheat. And we're going to talk through those two scenarios, okay? So let's talk through that. All right, so with this VAV box, right, first off, VMA is a application-specific controller, right? It's got the actuator built into the controller. We're all aware of that, right? Good? Okay, awesome. So we've got this controller, and it really has, if we're honest, 2 points, I would say, that we can go and really change things up, okay? So the first thing is our temp sensor, and then the second thing is going to be our airflow sensor. So when we've got a hot call or we've got a cold call, we have to understand what makes a space cool down. And it's air changes that are going to remove BTUs or add BTUs in the case of heating up a space. So if we need to remove BTUs and we know a space is hot, the first thing we're going to do, right, is validate that the space is actually hot. I mean, it's one thing if you're like me, a bigger guy who thinks everywhere is hot. But, for some people, it may not be hot. So we need to actually validate that it is indeed hot. Then once we've verified that our physical inputs are accurate, we have verified that it is actually indeed hot, then we have to say, how do we cool it down? Well, we cool it down by getting the appropriate cooling airflow. So the first thing I like to check, once again, is it all spaces or just one space? In this situation, we're going to say it's just one space. So it's one space. How does air come into a terminal unit, right? How does this work? So what happens is it comes from the main AHU, and it comes from that AHU into the terminal unit. So this is going to be our supply side, and this is going to be our discharge side, and our discharge side is going to go down to a diffuser, right? Okay, so we've verified that our inputs work. We verified that it's only one terminal unit. Now we need to make sure we're getting air to the terminal unit. So we make sure that we're actually getting air. And if we are indeed actually getting air, then we are going to go and say, okay, what's the next thing? Well, the next thing is going to be our damper. Are we actually able to modulate that air from the supply side to the discharge side? And that's pretty simple. We just command it open, we validate that it opens, and we validate that airflow increases coming out. So once we've done that, once we've validated that airflow, we're almost there. The next thing we know is that, okay, in order for us to get the supply air into the space in the right quantity, and right, we verified we have air, we verified that it's the right temperature, we verified our actuator works. Now we're going to verify our airflow sensor works. We take a mag gauge, hook it up to the airflow sensor, check our DP, make sure it works, do some calculations, make sure we got the right air. And if we get that air is coming in and temperature is right, and we've checked our actuator and we validated that that's stroking correctly, and we validated that we have the correct airflow, we've validated that that's the correct settings, we've checked the balancing settings if we have them written down, or our equipment schedule if it's written down there, and we validated that that's accurate, then the only other thing it could be is either going to be on the supply or on the exhaust side. Because remember, how spaces work is we have air changes, and those air, well, technically it could be like some third-party heat source, like someone having a desk heater under their desk, but let's ignore that, and or windows being open. So let's throw those out because it could be those as well. But from simplicity's sake, we have supply, and we make sure that the balancing damper right before the diffuser's open, so we're getting the right airflow out. And then we make sure that we're exhausting properly, and we make sure that our throw of our air is proper to mix. Once we've checked all that, you're usually gonna resolve the issue, excuse me, by the time you get to here. But you see, what I hope you all saw is how I logically walked through that. First thing I determined that it was actually indeed an issue with the terminal unit and not some higher level system, right? You all saw that, right? Okay, the next thing is I started working my logical path down the unit. Now, if at any time we got to the damper and we got into the program and we saw that the damper wasn't reacting properly to CFM, now we're moving from physical to logical, then we can start looking at PID loop tuning. We can start looking at our set points. We can start looking at our K factors and our box sizes. There's a bunch of logical aspects, but I always want to check physical first. And then once I've validated that physical is working, I will then dive into the logical. That's my approach to troubleshooting. So any questions on terminal units real quick before I wipe this off and we look at some network examples? What do y'all think? This is a totally new approach. I don't really see anyone out there doing this kind of approach in teaching. So I thought this would be kind of cool for us to do it this way. And you gotta forgive me, I'm getting over a little bit of a cough here. All right, not seeing anything. I'm gonna wipe this down and we're gonna get into network troubleshooting. Everyone loves network troubleshooting. All right, cool. So let's dive into some network troubleshooting. So there's so many issues with network troubleshooting that we could dive into. I'm going to dive into a fairly common one, which is a router going into a switch, which we're going to call subnet 1. And we're going to do a switch here, and we're going to call this subnet 2. Everyone know what a subnet is? So we're going to get to MSTP, Norman. That's going to be the third one we're going to cover. So, booyah, got you already. All right, so a router divides subnets. And on this subnet, let's say we go to a job site. And the customer is saying, Hey, I got the BAS server here. I love this example because it touches so many different things. All right. So we've got a router here. We've got switch, subnet 1, subnet 2, server. And then over here is the operator workstation. And so they say to us, we can't operate the server, or we can't access the server anymore. How many people have been there, right? You show up on the job site, you're like, we can't access the server anymore. We just can't. Okay, well, now we have to ask ourselves, how do we access the server, right? Well, a server typically is going to be accessed using HTTP protocol, hypertext transport protocol, and HTTPS, right? Across port 80 and port 443, typically, not always, but typically. So the first thing we say to ourselves is, from this operator workstation, can we ping the server? Can we ping that server? And if you can ping the server, then you know, without a doubt, it is not a routing issue. A route is a way that IP traffic is sent from one subnet, which is a different IP address scheme, to another subnet that is a different IP address scheme. So what I like to do is I like to rule out subnet routing, and I like to rule out ACLs and firewalls right off the bat. I like to knock those out. And here's how I do that. First thing I do is I do that ping. So step 1, I do ping. Step 2, I take my computer, I plug it into this subnet, so my computer, and I try to access the server. What I am doing by doing that, if I am now able to access the server, then what that tells me, right, is that now I have a firewall or ACL issue blocking port traffic. Excuse me. And because what I'm doing by accessing it here at the server is I'm negating, I'm bypassing any ACL, which are access control lists, or firewalls that exist in the router. So an ACL basically says, from this IP address range, deny or permit these ports to pass through, logical ports, not physical ports. Okay, so I've moved over here. I've physically isolated the router from the equation. If I'm able to hit the server, I know it's an issue with ping firewalls and ACLs at the router. If I'm not able to hit the server, then it's something else. My next thing I like to do, I like to try to log into the server. This is a super easy fix, and I've seen it so many times. You try to log into the server, you're able to bring up the server welcome banner, right? You bring it up and it says welcome BAS, whatever. And you go to log in. If you can log in with your administrative account, but the user cannot log in with their account, then it's most likely a password or a user right issue, because that tells you. So log in from the operator workstation to the server, Ryan. So good question. So if you're able to log in from this operator workstation over here to the server, then that tells you. Because remember, right? We checked ping firewall, we checked firewall ACL with our device over here. We ruled out that it was an issue right here. So now we're getting into troubleshooting the application. So what I like to do here is I say, okay, if I'm able to log in to the application, to the BAS application from my operator workstation to the server, then that tells me that it's most likely the user's password or their administrative account. Now, if it doesn't even come up at all, right? If it doesn't even come up at all, then I want to go and check a couple things here at the local layer 2 level, okay? So at layer 2, what I'm looking for is that the IP address, that the server is still up, right? So we validated that it's up because we're able to ping it. We've ruled out any ARP issues and any MAC address issues. I saw some folks talking about ARP because if we are able to ping, then we've ruled out address resolution protocol because there is a port, a physical port to IP matchup here. I know I'm throwing out so many IT terms for you folks, and some of you may be there, some of you may not. It's totally fine. Feel free to ask questions. I'm trying to keep it kind of 30,000 foot view here. So we've went and troubleshooted ping, we've troubleshooted firewall, we've troubleshooted user access. At this point, it is most likely going to be related to a issue with the web server. There's a couple different issues with the web server. One, we need to make sure it's running. Two, we need to make sure that the ports have not been reassigned. So for example, someone's running an Apache web server and they stand up an IIS web server, and now port 80 no longer works. Also, we need to validate that we're connecting to the right protocol. Oftentimes on BAS systems, they will keep port 80 enabled during construction so that they don't have to worry about certificating. And then they will enable only port 443 when it leaves construction phase and goes into warranty phase. And that often throws a lot of people because they have a port 80 address bookmarked and they don't have the HTTPS address bookmarked. And that's a very simple fix. To Barry's question, are you pinging by IP or name? If you're using DNS and DHCP, you definitely can ping by name because the DNS, the domain name, may actually be tied to independent, like a variable IP. If you're using just static IPs, then you can just use IP. So that's how I work through this at a high level. I'm going to take a sip of water, and then we're going to get into BACnet MSTP. Excuse me, folks. Nicole, who's my student success manager, always teases me to have a gigantic bottle of water because my throat gets dry whenever I do these webinars. So, all right, let's dive in to MSTP. So Norman, Address Resolution Protocol, ARP, is a table that exists in a switch that whenever you do a discovery on a switch, a broadcast on a switch, it's going to build that table. It usually stays live for 5 minutes. And that table is matching the physical port and MAC address to an IP address. That way, when you are doing your OSI layer 3 to layer 2 transition, it knows what to encapsulate, what Ethernet address to encapsulate IP traffic with. All right, so let's talk about MSTP, everyone's favorite topic. So, in my experience, there's only a handful of issues with MSTP. Sure, you're going to run into maybe like some fluke stuff with a shield adding interference or some issues with max masters or things like that. But most of the time, MSTP issues, they're going to be related to kind of 5 things. And how I like to approach an MSTP issue is I go to the customer and they're like, the controller's offline. I say, okay, well, how long has the controller been offline? It's been offline since we went and changed the controller. All right. Okay, so now we've got somewhere to start. Knowing that the controller has been offline since they changed it is going to be completely different than we had a lightning storm and now we have 5 controllers offline. You know, if someone changed a controller and it's offline, it's most likely like a MAC address or a device instance issue or a baud rate issue, something like that. If you have a lightning storm and all your controllers go down, it's most likely a transformer issue. So I'm going to talk through each one, kind of power. We're going to talk through duplicate MAC. We're going to talk about baud rate mismatch. We're going to talk about end of line. And that should take us pretty far. And then we'll get into the question and answer. How's that sound to everyone? Does that sound good? All right, cool. So the first issue, power. Quite possibly the simplest thing to work on. If you know RS-485 networks, you know one thing about them. The communication bus is decoupled from power. So that, 1.5 to 3 volt DC signal that is passing across that serial network, what happens when you lose power is those devices will go down, but you will still be able to communicate. So if you see, let's say these 2 devices are on T1, and this device is on T2, and these 3 are on transformer 3. Okay? So if these 2 devices go down, but everything else is working, it's a high likelihood that transformer 1 is down. This is also why I do not advocate having a massive transformer bank. I used to say, get a transformer bank of 380 plus VA with all those transformers stacked into, like a 16 by 20 box and put it in the plenum. I don't advocate that anymore because as I started to think about it more, if you lose the 120 source going to that transformer bank, you lose all those transformers. By having it potentially on multiple different transformer banks, multiple 120 sources, you now are segmenting your network electrically, so it makes it easier to troubleshoot and makes it more reliable. So that's our first issue, right? Is power. Now, unfortunately for us, end-of-line issues can look very similar to power. So an end-of-line actually is a resistor that dampens the reflection of the signal. Because how series communication works, when that electric signal hits that controller, the end-of-line resistor is going to dampen that electric signal and keep it from bouncing back. And that bounce back is going to be interfering with communication. The problem with that is if I turn this end-of-line on here, then all controllers downstream from that you're going to lose communication with them. So whenever I am looking for end-of-line issues, I look for, does it stop the controllers at a certain point and afterwards I can't see them? Then that is either an electrical break in the wiring or it's an end-of-line issue. So that's how I start to work that out. Okay, so next we have baud rate mismatches. So there's two kinds of baud rate mismatches. If the server is 9600, which by the way, BACnet supports 9600 and 38.4K. Those are the two required baud rates to be supported by any BACnet device. It's required that it supports those two baud rates. So if everything is like 9600, but then you have one that is 38.4, and the server itself is 9600, then you're probably going to have pretty reliable communication, except for that device that's going to intermittently go down and up. Because what baud rate, a lot of people think it's the speed in bits, but what it actually is the rate of change from 1 to 0. So remember, we're dealing with DC and we're dealing with ones and zeros. So baud rate is how many times you can change that 1 and 0 signal. So if we have a mismatch in that signaling, then you're going to have a mismatch in communication. And because of that, you're going to have data overflows and issues like that. So what's going to happen right here with this device, it's going to go down. Now, if you had a much higher speed at the server, or supervisory device rather, than every other device, then your issue would be that none of the devices would be communicating. You would have collisions. All right, so we've talked through baud rate, we've talked through electrical issues, end of line, and now we're going to talk through device ID and MAC address mismatches. So a MAC address issue. MAC addresses are how we physically address our BACnet devices. They're an 8-bit array that enables you to address from, 1 to 256, if I remember correctly. And MAC addressing is going to enable us to set the physical address of our device. But BACnet exists with two address types. You have your MAC address and you have your device ID, both of which need to be unique. Now, when you're dealing with that, MAC addresses have to be unique for that local MSTP network. Device IDs have to be unique for the BACnet network. So that device ID can have a conflict, and that will reflect in a device going up and down where you have two MAC addresses. Because when you do discovery, you're going to discover whichever device you get a response from first. And the same with MAC addresses. So that would be the sign where you have basically blinking devices. One goes up, one goes down, one goes up, one goes down. That's a sign of device IDs and MAC address duplication or mismatches. All right, so that brings us to about 1240. I'm going to take us back to the presentation real quick, and then we're going to go into question and answer. Alrighty, you should be seeing my screen now. So first off, I want to thank you all for being here. I do want to point out that our troubleshooting bootcamp, it dives into everything I covered today and much deeper. You'll get a follow-up message about this. You can check it out. We are doing a special rate for those who attended the webinar to purchase this course if you're interested in it. We'll send you some more information about it. I don't want to spend your time giving you a sales pitch. Just realize if you found our troubleshooting process valuable and you found how we went through that on the whiteboard valuable, then you'll really love this course. There's nothing else like it in the market. Let's now take some time to review this utterly amazing fact, which is that 100% of the questions that are not asked during the live question and answer session do not get answered. So this would be your time to go and answer these questions or ask these questions, and I'll be able to go and answer them. So I do see someone has a question about wire size and type for MSTP. Follow the 485 standard and you'll be good to go. RS 485, anywhere between 20 to 24 gauge, typically 3-wire. Doesn't require, surprisingly, RS 485 does not require shielded wire, but I would recommend shielded wire. Can you mix wire types? I don't recommend it, especially conductor types. I don't recommend that because you can have different levels of impedance. So, good questions so far. What do y'all think so far? This was a new kind of approach for us on doing a webinar. I'm curious what y'all thought of the approach. You like it? So let's see. What other questions do we have? Is device ID the same as instance number? Yes. Device instance, device ID. Some folks call it different things. Let's see what other questions we got in here. Let me move that off there. See, it looks like we got another question there. Oh, you're getting some questions in chat too. Oh, I'm sorry. Let me scroll up and go through that. Let's take care. All right, let me go to the top. If you have simple gateway devices that have MAC addresses, but the IT team is not able to see, ping the devices. Is that an ARP table problem? Not necessarily. So you have some, well, when you say MAC addresses, I'm assuming Ethernet MAC addresses, and the IT team's not able to see them. That could be a variety of things. I would go to the switch and have the IT team check the ARP table, and if there is a entry in the ARP table, then you know it's not an ARP table issue. And then you go to another device on that same subnet, on that same physical LAN, and you ping it, and then you know it's not an issue with the switch or the router. And so you gradually just work your way up. What is 232 wire type recommended? You mean for RS40? Well, RS485 is what BACnet uses, not 232. 232 is like Modbus. 4,500 foot length without repeater. It should be 30. Oh, wait. Okay. It should be 3,300 per segment, 3 segments, 32 devices per the RS485 standard. Have I ever seen where BACnet MSTP at the end of line is looped back to the start of the daisy chain? I've seen a lot of crazy stuff, but that completely violates the RS485 standard. But yes, I have seen stuff like that before. I've also seen a lot of T-taps. How would you troubleshoot DMX protocols for lighting? Treat it like a networking problem or electrical? So I've worked with DMX. I've worked with Dolly. You just have to understand the protocol stack and then troubleshoot each layer of the protocol stack, right? Obviously validating that the physical devices work, then troubleshooting the addressing, because here's the nice thing about lighting, access control, video surveillance, they all follow. I'm going to switch views real quick and then we'll come back to this. Okay, cool. The nice thing, like if I were to do this, right? So if I were to like put a server, supervisory device, controller, IO. This could be a BAS system. This can be a access control. Oh, because I'm 1 second. Like I said, we're still learning this. There you go. All right, now you're good. Okay, so server, supervisory device, controller, IO. This can be a access control system. So access control system, you could have the door controller right here, the main access controller here, and then the server with the access database. And you can have your card reader and your lock. This can be a lighting system. You can have the ballast and the light controller or the light switch. You can have the controller on the ballast going to the area or zone supervisor, going to the lighting server. Same with video surveillance. You can have your video system, and it'd be a little different in that the video system would most likely go to the video supervisor and then to the VMS, the video management server. But this 3-tier architecture, once you learn it, is very, very, very similar to how all of this works. Okay, so I just want to point that out. So like if I was doing Dolly or I was doing DMX or I was doing KNX or any of those kind of controls, lighting controls, protocols, I would start with my IO, move to my space controller, move to my supervisory device, and obviously troubleshoot the network components in between. All right, so let's move back. The switch. Boop. There we go. All righty, let's look at chat. Chat. Take a look. Okay, what do we got? I just lost chat. There it is. There's chat. How would I troubleshoot DMX? Question revolving the Eclipse 303 controllers. How do we discover them on the network and how do we address them? I would have to dig into that, Sonny. I'm sure I could go and look at how they're addressed. I assume since most of Distech stuff is IP, that they're IP addressed. I do know that they have this kind of sensor subnet that they use for addressing sensors. So I would assume you just do an IP discovery of them. We've been on the job 6 months as an apprentice and found the troubleshooting process explanation and steps to be helpful and logical without being familiar with the HVAC terminology. Awesome, man. That's super awesome to hear. Thanks a ton. Claude. We have multiple buildings. There seems to be an instance number conflict issues from time to time. Any clues? Visual BACnet. Do a Wireshark scan and use Visual BACnet by Optigo Networks. It's a very, very good tool. Really good at doing large scans and snapshots. I think it'll really help you out. Anything on the workbook yet? It'll be sent to you eventually. It's in the mail. We'll have that all figured out about the workbook. We tested, I swear to all of you, we tested it before the webinar. We tested it like 3 times. But still, it failed. Wah, wah, wah. All right. Let's take a look. Anything else? Is going on companies' LAN becoming more popular? Yeah, kind of, sort of. I mean, it really depends on the vertical market you're in. So, and it depends on the IT expertise of your business. So, if your company feels comfortable explaining and talking to IT folks, they're actually pretty easy to work with, and you can go on their local area networks. It's pretty easy to segment traffic on local area networks. It's not difficult. Now, if you're dealing with like the DoD or something like that, yeah, you're probably going to have your own OT network. So, with the network, do I ever use Wireshark? Yes. Well, kind of. I used to use Wireshark quite a bit. Nowadays, I find I'm able to resolve most issues without using Wireshark. So, okay, that one is answered. Company's LAN is answered. Are there more resources for learning Wireshark or the visual BACnet? Yes, we have a full IT course. We have quite arguably the best IT course in the industry because it's made specifically for building automation folks, and it dives into network troubleshooting, network servers, databases, cloud, APIs, everything you could possibly want to know about IT. And it's taught from a BAS perspective. So yeah, definitely would encourage you to check that out. Let's see again. Who is that again? We're making the change from MSTP to Siemens to Seago, which is Ethernet between controllers and BACnet. What is the best way to learn BACnet for our techs? I would encourage you to go through our BACnet Bootcamp. It's highly inexpensive. I think it's like $200. Man, I feel like this is turning into a commercial for our products. I really hope you all aren't feeling that way. I try not to do that. I always hate it when people like hoodwink you into a webinar and they're like, hey, come. And then it's like 10 minutes of teaching and 40 minutes of product pitch. But I really encourage you. I really believe in our products. Check out our BACnet Bootcamp. It's really damn good. But let me talk through that, okay? Let me talk through some kind of things on the whiteboard real quick. Ooh, I love this. This is so much fun. Okay, hold on. So let's talk through BACnet. All right. BACnet ring topology, which is what you are using when you are working with Siemens and in their architecture, right? So you got a supervisory device. You've got your controller 1, controller 2, controller 3. And we cover this in our IP controls design and implementation bootcamp. But basically what happens, and this is new for a lot of folks, what I want you to think about this architecture, this is a ring architecture. There's also a daisy chain architecture with BACnet IP, but we're going to cover ring. What I want you to think about with this ring is it is really no different logically than this. So let's say this is a switch 1, and then you got the supervisory device coming off of it, right? This is no different. This equals this. So logically, this switch sees it as 3 individual controller links. Physically, you have rapid spanning tree protocol. And I forgot for the life of me, I've got a pretty darn good memory, but for the life of me, I don't remember root port, that's right. So this is our root port and this is our blocking port. And with our rapid spanning tree protocol, what happens is it looks for a failure. So the problem with IP controls, and this is largely being fixed by a lot of manufacturers, but the problem is that the IP Ethernet connections are physically coupled to one another. So if do I have one? Hold on, 2 seconds here. I know I stepped off screen. That's like super unprofessional, but whatever. All right. So this is Edge 10. It's actually a Cypher 10, but you can see, right, you've got a primary and a secondary, so you can do ring architecture here. Now, what's going on right here with this and this is that these are not electrically isolated. So if you lose right here, if you lose the connection, if you lose electrical power to this, then you're going to lose the network interface card that's inside of this. So the problem with that, right, is that let's say this controller goes down, controller 2, boom, loses power. This IP message is not going to pass through. Now, manufacturers are working on passing this by using basically some switching that would automatically fuse the connection to pass through. But a lot of products don't have that right now. So what happens then is this root port's like, oh crap, there's now a break. It's not a ring anymore. And so it stops this blocking port and it opens up this blocking port since there's no longer a loop, and it allows traffic to flow. So you will now have traffic to C3 and C1. And so that's how rapid spanning tree protocol works. And I thought that's pretty important for you to understand, especially now that we're getting into a lot of IP ring architectures, because you have three patterns, right? You have the star pattern, you have the ring pattern, and then you have the bus pattern, which is very similar to the daisy chain pattern. All right, let's switch back to the other camera. Cool. All righty, let's take a look. Is there a scan tool in Metasys to find a total count of VMAs, all that, without going through each NAE? There was back when I worked for Johnson Controls. I don't know what they have nowadays, but there was, there were a couple different tools, right? You could do Mel, Mass Edit Live. You could do all sorts of stuff from a scanning perspective. Nicole, you linked to BACnet. If you want to link to the IP networking bootcamp and the IT course for anyone who's interested in that, as well as the troubleshooting course, since that's 50% off for the next week. How important is clean power coming into the building from a hardware perspective and software stability? I mean, it depends, right? So there's a difference between clean power and stable power. So clean power, it's okay, but most of that should be handled by upstream distribution before it ever gets down to secondary. Actually, I guess it would be tertiary power loops. Stable power is extremely important. That's why you should have UPSs on any systems that are potentially going to go down, but yet need time to process, like supervisory devices and advanced application controllers before they shut down. Most of them have some sort of battery backup built into them. Please speak on MA troubleshooting, specifically MA output testing. I heard that you can bring it down a plant. You can. So Alexander, here's the issue with MA output testing. If you don't have an amp clamp, and funny enough, we talked about this in our live office hours on Monday, I believe, with students. Maybe it was the YouTube live stream we did. I do so many live things, I have no idea which one I talked about it in. But basically, in order to test current, you have to test it in series if you don't have an amp clamp. And so what I mean by that is you have to actually physically interrupt the wire and run your leads on your multimeter between the wires. So you can actually take down valves and all sorts of things that are dependent on a milliamp output. Unless you have an amp clamp, which I highly recommend. They're only like $150 to get for a Fluke multimeter. Like you can get the ones that go right on your Fluke multimeter. And yeah, okay. What do you see as future issues that we will face in buildings, more networking? I see the biggest issue you all will face in buildings is once the economy stabilizes, coronavirus is over, the older generation leaving the workspace. So all these legacy systems that they maintained that you can no longer buy parts for, no one's maintaining them, and you're going to see a massive rush of retrofits. I was forecasting that last year. Obviously, COVID hit and that delayed that, but I still think that will happen because we have a very aged workforce that are dealing with a lot of legacy systems. And once those folks start to leave, you're going to have no one who can support those systems anymore, and you're going to see a huge push for retrofit. Do, 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 do. Ah, cool. Awesome. So anything else? Was this a good use of your time? I hope it was. I hope you look back on the webinars you've been in right now in 2021 and you're like, man, this was kind of cool. I hope this sets the standard for all the webinars that you see moving forward. We're going to have another webinar on February, and it is going to be on, let me pull it up and I will tell you, webinars. It's going to be on control engineering. We're going to go through how to create a hardware engineer, how to engineer hardware. So how to select points, how to size valves, all that stuff. Then in March, we're gonna have estimating for building automation. And in April, we're gonna have point-to-point checkout, where we're actually gonna do some point-to-point checkout on the board behind me. So yeah. I do encourage you all, if troubleshooting is at all interesting to you, or maybe to your customers or your team, the course for until next Friday is going to be 50% off. And if that's at all interesting to you, I really encourage you to pick it up because it's going to go back to its normal price of $2,000 on the 22nd. So right now it's half that. Need a call. This was helpful. Will this be recorded and available? I think so. Maybe. Yes. It says it's recording. Anyone who's attended my live office hours and past webinars know that recordings and Phil Zito do not necessarily have the greatest relationship. They don't like to work. Are they live courses or self-study? They're a hybrid, actually. So they're self-study, but you have live office hours and you have our discussion forums. So you're going to have live office hours 2 days a week where you can hop in and ask any questions. And then you're also going to have discussion forums. We have a lot of students of ours in here that I'd encourage you to just ask their experience. Can I do a trunk scan? Unfortunately, I don't have my system set up to do that right now. I do have a whole controller wall right behind me, but it is off right now. It's not on. Thank you, Lee. I appreciate you saying that. One of our first students. So, yeah. Anything else I can answer for you all? I'll stay here till you all have no more questions. This is your time. I very much value it. I want you to leave this with amazing value. And so, yeah, feel free to ask. And Nicole, I brought a gigantic water jug this time. I just keep talking so long, I don't ever get to drink from it. There we go. Anything else? Give you all a couple minutes. For those of you who are individuals who are like, man, I want to convince my boss to let me purchase a course, a couple things to tell you. One, we have a request a course training template from my boss that is on our website. And you can get it by going to smartbuildingsacademy.com, going to how SBA works, info for prospective students. I'll throw it in the chat here. We also have payment plans now. Everyone's been asking for that. So we've got this thing with Split It. So yeah. We have trouble with US funds. I believe our Shopify store takes any different currency, takes all sorts of currencies. So. Just before I lose y'all, anything you all would like us to cover moving forward? Any topics you would like us to do webinars on? I mean, we've already got a pretty long list of stuff. But hey, I'm open to ideas. You're welcome, anonymous attendee. That's awesome. It would be even better if your picture was anonymous. There you go. Oh. Advanced Niagara querying. That's a good question. Yeah, I mean, we could talk through BQual and see, you said it. Yeah, we could talk through that. I mean, I wish I knew where I saw that like BQual query template doc. But yeah, using that, using a batch, using the program editor, things like that. Yeah, maybe I teach a course on that. I know I go through BQual in our Niagara course. So enjoy the snow. Thanks, I guess. We're going to my daughter's jiu-jitsu tournament on Saturday because she wants to be an MMA fighter. Yeah, I don't know how I got a child who wants to be an MMA fighter, but whatever. But she's doing that, and it's supposed to be snowing like crazy, like all weekend. So it's going to be very interesting. And you said retrofits. I'm talking about the control systems. So retrofitting the control systems. You've got a lot of legacy control systems, and I think people are going to want to retrofit them. You're welcome. Thanks. So yeah. Oh, by the way, if you don't know, AX is, at least last I checked, Tritium AX is end of lifing June, maybe July. So that is going to be interesting. That's going to open up a lot of opportunities. June, yeah. See. So if you're looking for some controls work, get your SMAs, get them now while they're still there. No, but yeah, I mean, seriously, that's some like serious control retrofit opportunity. That is like big. I mean, that's like 50% market share of controls. And I got to imagine, like, of that base, it's probably still 80% AX, maybe 70% AX. Webinar on retrofitting older systems. I actually want to teach a retrofitting course. I want to teach like a retrofit design and sales course. I think that would be interesting. But I promised my team I would not create any more courses. Because we're rolling out a new solution that's going to be focused on people who aren't in the industry yet and upskilling them so they can get hired. All right. Cool. Well, I'll wait a couple more minutes, see if any questions come in. And if not, then we'll call it a day. Ugh. The best approach to retrofitting a pneumatic system. Hold on, I'm telling Nicole to check OneNote. Nicole, I think we need the OneNote link, not the SharePoint link. I think that might be the issue. What's the best approach to retrofitting a pneumatic system? Well, I wouldn't say there's a best approach. I'll tell you my thoughts and, take them as you will. Start with the terminal units. Those are the things that are going to give you the most complaints, and you're going to, have the most of them. So the easiest way to do that is get one of those stats that actually is wireless BACnet and has an E to P transducer built into it. So it will be able to sense temperature and control the damper. So do a bunch of those in lieu of replacing controls. Those are pretty reliable nowadays. There's multiple manufacturers of that. Then from there, move to the air handling systems. You're going to need to replace the inlet fans, most likely with VFDs. On the fans, you're going to have to replace most of the actuators with E to Ps. You'll keep the pneumatic actuators, but replace them with the E to Ps. And then you're going to have to put in sensors. And then from there, you would move to the hydronic plant. So that's what I do. All the while being careful for accumulators that are maybe taking up DAT values from air handlers and then resetting plant control, or zone temp values from terminal units and resetting DAT on air handlers. So you got to be careful of those. But my approach with any pneumatic retrofit is always starting with the terminal units, moving to the air handling systems, and then moving to the hydronic plants. So yeah, that's how I would do it. That's how I have done it many, many times. Unfortunately, I always got stuck with the pneumatics jobs. Anything else I can answer for you all? Cybersecurity. What about cybersecurity? That's like saying football or snow. I mean, there's so much to that topic. Is it getting worse? I don't know. So you gotta be real, right? So there's a lot of people out there who stand to make a lot of money. Like, okay, so you all know I don't like BACnet SC, right? That's not a mystery. I mean, I've been pretty vocal about how I think it's like the stupidest idea we've ever come up with. Let's take all these IT security standards that already work and let's make a BACnet version of them, because that's real smart. We're finally getting the trust of IT groups, and now we're just gonna like BACnetize cybersecurity and make everyone confused. So, yeah. But is cybersecurity getting worse? No, I think it's the same. Honestly, like most people have a administrative and a physical security issue. They don't have an IT security issue. I get these people who are like, if you have IP controls, they can go in and they can go and take the controller and replace it with their own device and hack into your network. And I'm like, isn't the fact that someone's in your ceiling with a ladder, like jacking into your controls, like kind of a bigger deal? I mean, that's a major FISEC, so physical security issue. Or the fact that everyone uses the same username and password, and we let people go and like have full administrative control of their servers and download anything they want on them so that they get phished, and then we have no cyber security software running on our servers because we don't want to have to figure out how to do firewall and application exceptions so that those applications can run. I mean, that's the real issue. You fix FISEC and you fix administrative security, and you will fix the majority of the issues. Yeah, sure, there are some software that has holes in it, like legacy control solutions that haven't been patched. But the reality is most of the stuff you're going to fix just with administrative and physical security controls.